Okay, so today you're going to be looking at this chi-squared two-way table problem set, and there's two problems in here, and one I'm going to walk through as an example, and the other you're going to do on your own. Okay? Okay, so we're going to use problem number one as an example. Number one says the non-profit group Public Agenda conducted telephone interviews with those. There's a typo. It should be three. There we go. Three randomly selected groups of parents of high school children. There were 202 black parents, 202 Hispanic parents, 201 white parents. Okay, so one question was asked: are high school schools in your state doing an excellent, good, fair, or poor job? And don't you know enough to say? Okay, so here's the survey results. So in order to do the chi-squared test here, you have to ignore the total column and the total row, right? So in this case, I have an excellent row, a good row, a fair row, a poor row, and a don't know row. So I have 5 rows. So it's 5 rows. I have 3 columns. I have a black, Hispanic, and white column. Okay, so 5 minus 1, right? Because degrees of freedom is rows minus 1. So that's going to give me 5 minus 1 is 4. And then degrees of freedom is columns minus 1. So that's going to be 3 minus 1 is 2. So it's going to be 4 times 2. I'm going to have 8 degrees of freedom in this table. All right, so let's get that table into the calculator. Okay, so let me bring this over to the left. So I have the table and I have the calculator all on the same screen here. There we go. All right, so how to get the table into the calculator. I'm going to go into second, and it's this X inverse button, allows me into matrices. And I'm going to edit, and I still have old data in here, and that's fine. If it makes you feel uncomfortable, just like you can clear your calculator or whatever, but you can just overwrite it. My table here has 1, 2, 3, 4, 5 rows, and it has 1, 2, 3 columns. Okay, so let's get that data in. I have 12, 34, 22, 69, 55, 55, right? 81, 75, 61, 60. Okay, 24, 24, oops, 24, 24, 24. Okay. And then 22, 28, 14. So this is all I need. It's just the meat of the table. I leave off the total column and the total row, right? So I tell it rows, then columns, put the table in. Okay, so always good practice here is to go back to the main screen, right? And then I'm going to go stat, tests, and I go down to the chi-squared test. A, B, and I calculate. Oh, wait, yep. It actually came up with the degrees of freedom for me. It's 8, right? Because it does that. And it gives me this p-value of 0.004. Okay, so p here is relatively low, right? Like if I think about this, my p-value here is definitely like not gonna hit like alpha. Like if I like make alpha being, let's say, 0.05 or even 0.01, my p is less than most alphas, right? So this tells me that like my table does not show it doesn't show independence, right? So there is some sort of correlation between race and response here. Okay, so I reject the H null because the p-value is low, which means that there's some sort of correlation between the race and the response going on here. Now, always a good practice is to go in and look at that B matrix, right? And kind of look at like what should have happened in comparison to what did happen, right? So this B matrix here is kind of got a lot of data in it, but I can move around in there a little bit, I think. Let me see if I can get the B matrix one more time. So I'm like moving in it. Or it's probably even easier if I just like edit the B matrix, because that way I have a lot more control. So let's go over to edit the B matrix. I'm not going to change anything, but I'm just going to look at it, right? So like if you look here, we should have seen, like if you look at the excellent column here, right? Like you should have seen 22 black parents saying the schools are excellent. You only have 12. But the Hispanic parents are like higher than we would expect, and the white parents are like right on cue there, right? The good levels, the Hispanic levels drop, but there's kind of like an increase toward the excellent there. And so what I'm not asking you to answer the questions in these ways, but I think it's worth looking back to see what you see, right? And to see what was expected and seeing like where was it off. Like if you look kind of down to the poor, we got exactly what we would expected. They're all in line with each other. The fair are not too far off, right? It's in that good and excellent range where we see some disparity here. It's just one of those things where you get a chance to kind of figure out where are the contributions. An easy way to do this actually is to like take, let's take and make matrix, let's stop. Whoop. What do I want to do? I want to take matrix A, right? Matrix A is my observed, and subtract matrix B, which is my expecteds, right? And I'm going to store that into matrix C, right? This will give me an easy way to see like where some of that disparity is. So like if I go, matrix and edit that matrix C, I can see where some of the biggest jumps in the numbers are. And like, there we go. The Hispanic number for excellent is way high. I get 11.2. The white number for good is like 12 over the top, and the black number for excellent is below by like 10.7. So that kind of will help you kind of pinpoint some of the places. Ooh, and the Hispanic number for good is like down below by 13. So it can give you a way to kind of like be conversant about the data, like after you've determined that it's not independent, to be able to just kind of get there. So like it says, do these data provide convincing evidence that the distribution of opinions about high schools differ from the three populations of the parents? And yeah, I mean, like we rejected that there's independence here, right? So the simple answer to that is the P score was low. There's a correlation between race and response. So we do have convincing evidence of that. All right, so I hope this gives you an idea of just kind of like how to perform the test and some of the ways to think about it, how to get to a succinct answer in the end. And, so your job now is to like do problem 2 and kind of go with it from there. All right, so good luck.